forward to technical session 2, featuring the keynote session on modeling and performance evaluation techniques using Python. Now, I request today's chairperson, Dr. Satish Shetty sir, to felicitate our resource person. I request. Now I request Dr. Developents to take chairperson, Dr. Satish Shetty sir. Thank you. With the permission of the chair, the session will now move forward. The distinguished resource person. Now I request Dr. Satish Shetty sir to introduce our resource person.
Good afternoon. I am here to introduce the resource person. I am here to introduce the resource person for this technical session 2, Professor Dr. Ramesh Manda sir. It is my privilege to introduce Professor Dr. Ramesh Manda sir, Professor in the Department of Computer Science and Information Technology, Dr. Babasaheb Ambedkar, Marathwada University, Sri Chhatrapati Sambhajinagar. Dr. Manda sir holds a PhD in Computer Science with specialization in image data compression. With more than 2 decades of the teaching and research experience, he has made significant contributions to the field of computer vision, biomedical image processing, remote sensing, and image processing. He has authored and co-authored numerous research papers in reputed international journals and conferences, and has also contributed to several academic books in areas such as computer vision, information technology, and knowledge engineering. Dr. Manda sir is an active member of professional bodies including the IEEE and the Institution of Electronic and Telecommunication Engineers, that is IETE, and has been associated with organizing and contributing to many national and international academic conferences. We are honored to have such a distinguished academician with us today. Sir, now I request you, please start the session.
Thank you, sir.
Hello. Good afternoon. Today I am here to discuss different modeling technologies used in data science, and the examples which we will discuss today are implemented in Python programming. So initially we will start with small data set with very few number of variables. Then we will increase number of variables followed by size of data set, and meanwhile in every example we will see how to build a model in Python, followed by how to evaluate that model manually as well as with the help of libraries present in the Python. So this way we will go proceed further. Meanwhile, on any slide you can interrupt me. We will try to simplify. Okay, so better if you make it more interactive. Let me express my sincere thanks and gratitude to organizer for giving me this opportunity to be part of this international conference. I am also very much thankful to the YouTube channel, one of the best channel for data science resources, machine learning resources. Another beauty of this YouTube channel is it is multilingual. It is in Hindi as well as English both. So you can refer this, and few of the points I have used from this tutorial point to prepare my PowerPoint presentation. So let us start with machine learning, where in manually we used to do, for example, to multiply these two numbers. It is because of larger number it will take maximum time, but with computer it will do with fraction of second. So it is one of the basic example of machine learning. Another is to search something through manual process, records, okay, like NAC or library records, any past record present in the office. So it is also tedious job, but same thing can be happened with the computer with fraction of second because of the machine learning. This is another example where how the training is important. In machine learning, training part is very much important because computer is dumb and deaf person. Until we will not provide complete detail what to do, it will not do by computer by itself, right? This is the example. If we will not provide proper details, this may happen. And whereas in manual, it can adopt the things according to the current scenario and take the decision. What happened during the natural processing? In our case of human being, we slowly learning the languages, start from alphabets, words, sentences and so on. Same thing we have to do in machine learning. We have to train the computer like we train. Okay, so it will having around same process, and based on that it has been developed. So our objective is to make a computer intelligence which will work like we people. Okay, so that is the basic things in machine learning. And we have natural language which we will use to talk, interact, etc. Here in computer also now with artificial intelligence, natural language has been adopted in machine learning. What is there in natural language? We have the neurons present in the brain. For every new things which will come across, the neuron has developed, new neuron created, and it will kept in the memory. Wherever second time it will come across, it will read followed by cognize. Read means we will accept second time. Cognize will match the process with the memory, and then it gives response. Yes, I have come across earlier. This is X, Y, Z, and so on. Right? The same process is there in machine learning. We first train the computer and followed by test the computer. Right? So in machine learning, both the parts will come across. For training purpose, here neural network is used. What is there in neural network? We have certain set of inputs and certain set of output combination, right? But whatever group of input values has been provided has been combined, permutation combination is done, and the rate is measured at output level. Out of total possible combinations given as input, number of output having higher rate will be the output. So the same thing is there here also. For example, if we give input this picture, right? It has certain features. Those features out of 3 inputs carries by 2 values. Then hidden layer is the processing, which is actually mathematical model having certain operation, mathematical operation onto the given set of input features, and it has generated the output. There are 2 outputs, but out of these 2, first one has generated higher weight, higher value, and hence it match with the cow picture. If we change the orientation, color, etc., still it will give the higher weightage. Whereas if we give the another picture like car, what it does, the input out of 3 inputs, it has given the output weighs to second, and hence given the output as car image. It has followed by cognition, right? The same thing we do through training process. This combination and matching is done based on knowledge base, which sometimes we may call it as database provided with information. On top of that, we may have algorithm, we may have flowchart or program, or now in artificial intelligence tool, directly inbuilt AI tool, where simply we supply the input and it will generate the output. But in background, it has to follow all these steps. The another things involved along with machine learning is deep learning followed by mathematical model. In machine learning, we human being give the intervention of coding and decoding. Through deep learning, this coding and decoding is done automatically. We will simply give the set of inputs, rest of the things will handle by the deep learning tools. Okay? And through mathematical, manually we have a choice to select the tool, to select the algorithm and generate the different types of outputs. Now why it is widely used? Like through artificial intelligence and the resources available on the YouTube, we can use it in wider set of application. For example, filtering the spam images coming in the inbox. So it will do automatically based on keyword present in the subject as well as body of the email. Based on that, it will do a filter and our email will goes to that appropriate folder. It will reduce the time to see, it will reduce the time to directly delete them, because we know spam we do not want. Nowadays, commercial, purchase, etc. has been filtered during the real-time example, and it will filter out. Sometimes, suppose for example, if we write the email to the friends, depends upon which type of content we are sharing, it started to give the notification. Suppose in our content we may have information related to vehicle, so we started to receive the email, auto email, that how you can sell your second car, how you can purchase the car, etc. Right? Suppose resignation we have been sent to the authority, immediately what are the new jobs available to match with the profile, right? Such type of filtering is done, and that is through machine learning. This voice-based searching is available in most of the cases like Alexa, Siri, etc. And now for calling also, most of us will directly use call XYZ. So it will search the number and dial, right? So voice-based, because of multimodal facility, it has been expanded the services. In YouTube, what happened? Based on the user's searching pattern, it will identify in which area we are interested to, and that type of new advanced notification will come. What is the new development in that particular area? So behind that also we do have machine learning. In this driverless car, the cameras along with sensors measure the distance, then the obstacles present on the road and take a decision to drive. Let's select the car. माउस नहीं मिला हमारे नहीं हाँ माउस मिला नहीं मिला इंटरनेट डोंट नो ठीक है So now we will start with the actual implementation of machine learning, where first we start with linear regression analysis, the first most technique used for prediction, and machine learning is totally based on prediction. It is purely statistics. Okay, based on that it will do the prediction, and output generated by that prediction will be used to take the appropriate decision. In all the examples which just we have seen in first PPT, all of them are take their decision based on prediction. Okay, so what we will do through prediction, that we see as discussed earlier with small set, number of variables small, then increase variable as well as data set. First example we will take where we have area and price, built up area and price of the house. We will find the price of any new built up area. Okay. So for example, based on this given data set, we will train the model and ask to find the price for 3300 built up area and 5000 square feet built up area using linear regression analysis. In normal case, what we do, we take a data, have a scatter plot, and scatter plot is area with respect to price. For manually, we may take the intersect of two lines, vertical, horizontal, and that intersect point can be the price. This will do manually. Same we have to do with computer. Okay, for that what we need to understand is we have to find out the best suitable line for the given data set. Why? Because here, like this single blue line, it is possible to have more than one possible line passes through the data. So out of them, we have to first find out which is best suitable line out of them. Best suitable line we will further utilize for testing. So training means finding this best suitable line out of total possible. For that what we have to do, we have to start the process of training. In that, out of multiple possible, randomly we will select any one. For example, this is the first line out of possible. We will measure the difference of every point from that line and summation of all the difference. 5 points are there, for example. So summation of difference of all 5 points for line number 1, L1. Same thing we do for L2, line number 2, line number 3. If we have n number of lines, total n number of lines, square of difference of every points will do, and there is summation. This value will give you mean square error that MSE will utilize to select the best suitable line out of possible, and that ends the training process. I'll repeat, we started with data point in scatter plot, draw all possible line, out of them our objective is to select best suitable single line that is selected based on mean square error. Mean square error is square of difference of every point and their sum, right? So this is training. Actually in machine learning, in background this is called training. Once we find that we can do the comparison or evaluation with line equation y is equal to mx plus b, where y is the value which is we will generate, so it is dependent, m and b are constant coefficients and intercept. Here x will change. In our example, built up area is the x value, right? The beauty of this is the independent variable area will change and the rest of the things will remain constant, right? Same thing we can give inputs through regression analysis, and same line equation we will use for verification of the model. Here the number of variable is 1, x. If we have multivariate, then it will be m1 x1 plus m2 x2 plus m3 xt up to b. Okay. So dependent variable price, area is independent, we put the value of area and generate the price. This way we first install the Anaconda or Jupyter, wherever you are comfortable to, for implementation. According to operating system, you have to select the appropriate version. Okay, let us start with the implementation part. Given objective data is given, we will simply write the data in Excel sheet, Microsoft Excel. That file we will read in Jupyter. Okay, so in Excel we have created two columns, area and price. To read that, the libraries we do have are here the pandas, numpy, these are necessary libraries required for processing. Followed by the first line to read is the object of this object of this library pd dot read underscore the Excel sheet and followed by name of that Excel sheet. It will read and stored into user defined variable df. If we type df here, it has given the contents of that Excel sheet, so area and price both. Now we got data in Jupyter. We will further draw the scatter plot from that data. So for scatter plot, plt dot x label y label followed by plt dot scatter plot with parameter price and area. So it has got the scatter plot. Now for prediction, we have to draw the price column, because that we are going to calculate using y is equal to mx plus c of linear regression. So hence it has draw price and orientation is column. Only linear regression model, and what it consists of, the model consists of the parameter to evaluate. So here it has shown draw. Now once model is there, we will fit the model. Model fitting means training, means finding best suitable line out of total possible is the fitting process. So what it does, fitting is done with new df. In new df, price has been dropped out and actually price column. By using these two parameters, it will fit. We also called it as training. So we got the output as fit model. Now we will compare this with the testing procedure, right? Once it is trained, we do go for testing. For testing, function is predict. The parameter for predict is model.predict and built up area. Built up area is written in double square bracket because it used to have 2D array. The syntax must be 2D array. Hence it has enclosed in double square bracket. So it has got value of price for this much built up area. Okay. Now we'll evaluate. So second built up area 5000 got this much price. Now we'll evaluate. For that the base is line equation.
For evaluation purpose, we need coefficients and intercept. So we say model dot coefficient value of m, model dot intercept value of b. We put that in y is equal to mx plus b, where this is m x plus b. This and this is same, right? So it is evaluation process, right? So first we have to take the model, give the inputs, right? Train it, followed by test, and then evaluate, right? The manual evaluation, same thing we can do with automated also. For 5,000, now only one value was there for x. If there are multiple, then we have to supply the array of built up area at a time. So multiple value also it will generate the same model. So it has taken the new CSV file area.csv. It has around 13 values. Call the same predict function. No need to retrain the same model, which is already trained. Okay, we can reutilize it multiple times. So list has given, that's why output of prices are also the list of 13 values. That price we can put into data set. So area underscore df in column heading price, it will copy the contents of this p. P is the output generated, and we got the value of respective built up area, price of respective built up area. So it will write back onto data set as well as in Excel sheet too. So through this line area underscore df dot to CSV, it will write CSV file from the data set with name predictions.csv. If you open the folder, it has got that CSV file. We double click and open, it gives the prices, okay, respective built up area and prices. So here it has shown the interaction from Excel sheet to Jupyter and vice versa by taking the inputs, evaluating, and again creating the Excel sheet. Based on this, the exercise can be to find out the per capita income of Canada, where the data set is given over here of univariate. We can utilize it to evaluate. So the expected answer is like this. It has shown on the this GitHub. You might be aware about the GitHub, where open source large size data set along with code implemented in Python is given. Yeah, if there are any doubts, we can have 1 minute to discuss them. Any question? Shall I proceed? Okay, let us proceed. So up till now, single variable we have seen of. Next and last. Now we will see the number of variables increased by number of variables. We will increase now number of variables. So along with built up area, we may have the number of variables more than one. Example is same using built up area, how to find the price. Now variable increases are number of bedrooms, age, and price. Okay, so these two along with built up area, these two increases. Another things we have to handle over here is this missing value. We have to find out the missing values, fill that missing value. Process is called pre-processing or data cleaning. Any one term we can use. How to fill it, that we will see in successive slide. The example is multivariate. Okay, and once we train using this data set, we have to find the price for this given two examples. Same line equation, okay, but with multiple variables, multivariates example. For generalize, it can write to any n number of variables. So this is nothing but model. This is model in case of machine learning. This is the model. Okay. The beauty is in machine learning, the beauty is input is also known, output is also known. We have to select the appropriate model and using that find the output, try to match with the actual expected output, right? So this is the beauty in machine learning. Target we know already. So we'll start with pre-processing or data cleaning, where we will blank space is identified with NA. Okay, those values will find out. Why NA will come? Due to the acquisition device through which we will capture the data. Due to limitation of that, the data might be missing. Okay, or certain manipulation arithmetic operations might be miss out the data, or in computer due to transmission medium error sometimes data might be missed out. So to overcome that, we have to first handle those missing places. Here what we do for that, we either take median, average, mode, etc., or simply replace it by 0. It varies from case to case. So for that we have here Jupyter, right? Excel sheet created from that given data set with example. Libraries are pandas, numpy, sklearn for the linear regression model. This is the statement to read Excel sheet into Jupyter, and we got the value. Missing value is indicated with NaN. That we have to first determine and followed by replace. So once we read, we do with median in this case, okay, and as we change the replacement of missing value function, output will vary. So median, we got median of this column, median of bedroom, this column, so it is 4.0. Now with this statement, it is fill NA, it will replace the blank spaces or NA with this function. And see here, on the row number 2, 4.0 is written in place of the null value, blank value, right? So directly it has been written here, and the pre-processed clean data set is like this. Why we need to clean? Otherwise it will generate the wrong result, right? So we need to first clean the data set. In machine learning or data science, data cleaning is most important step and first most step. Then come to linear regression model, create a model, fit the model, fitting again, training or finding base suitable line with dropping price column, price with orientation column. This we will drop and train the model. The process of training is fitting. So we got model train. Now we have to predict. So model got predict with the first combination, 3000 built up area, 3 bedrooms, 40-year age. We got sum total price. Okay. Now let us reduce the age. Earlier 40, now 10. We got higher price. Any one parameter if you modify, price will change. Okay. So it is multivariate. Similarly, we will evaluate. So for that, what we need, value of MLB coefficient. 3 variables are there, hence 3 M1, M2, M3, 1 intercept. Right? We'll put those values in line equation here and compare the predicted value with mathematically calculated. So 3 values, 3003 bedrooms and 40 age. With coefficient intercept, we put into this equation and we got the same price, these two. Okay, so it is evaluation purpose. Another example, 2500 built up area, number of bedroom 4, age 5, so we got this price. With the same way, by putting them into line equation, we can evaluate the working of that model. Here, based on this same example of multivariate, we have an example to predict the salary of employee, and for that purpose information available in the given inbuilt data set is experience, test score conducted, interview score conducted, and the salary. This is the given data set. We have to use this for training the model and then followed by test for these two given cases. Related to this data set is available on GitHub. The expected answer is also given for the evaluation purpose. Yeah, is there any doubts, any question in multivariate? Shall I proceed? Now we will move to the gradient descent function for the purpose of selecting best suitable line. In earlier example we have used mean square error. Here it is also called as cost function, gradient descent. As we have seen in machine learning, this is the model that we have to select. Input is given, expected output is also given for comparison, either we are moving in proper direction or not. So our job is to select this. This selection is based on trial and error. We modify the equation, check the output generated with this expected, and based on the error between these two, we modify these parameters in training process. Okay. So the same example, like to find given area, prices, we have put them into line equation and evaluated through the line equation in earlier slide. Where we have done based on mean square error, selection of best suitable line. Now here, in spite of that, we will use cost function. Okay. So slightly modification of the equation. Here square of differences followed by sum of square of differences followed by division of number of values present. Okay. And it is cost function. The square is done to convert negative into positive. See, another thing is this is MSE, mean square error, yi actually generated by that model, and y predicted is the value of model, yi is expected, which is target. So we will take difference between these two. Okay. So cost function is fine like this. Predicted means the mx plus b line equation for prediction. Another way we check with how it will do through 3D model. In 3D model, like this model. Okay. So let us see with the coding implemented part. Through the training process, the iterations are performed. Number of iterations are performed, and in every iteration we have to change the parameter, which is human intervention in machine learning. Same thing in deep learning, automatically handled. So let us remember the parameter value. Number of iteration means for loop 24 times. M coefficient is 0.67, intercept is 0.01. For this set of values, if we evaluate this equation, the line is somewhat closer to data sets, data points with this parameter. Okay, and this is simulated version. It has increased the length, and this will come, red line come closer to data points as we modify these 3 parameters. Just check. earlier 24.67.01, second time 41 iteration, M 0.95, B 0.02, and we got the line more closer. Data or the line equation is remained same, right? This has happened in background of finding suitable data line. 64 1.18.02, it has come still more closer. Okay, then 110 1.39.03, and it has come approximate a part of data. Okay, so this way also we are going to find the best suitable line. Another set. Okay, the same thing we can do in fourth way of 3D, like instead of directly going to 3D, we convert them into 2D, where we take B over here, M over here, right? And target is this point, this red point in both the cases. We have to reach to this by varying this set of data points. Okay. So, if we do this variation with constant rate of change, if we follow, it will skip out this target. If we keep the variation for every iteration constant, we may skip this point. Hence, we must have for every iteration rate of change of M, B, and number of iteration dynamic for every iteration. For every time in that loop, it must dynamically change. Then only we can reach to this target. Otherwise, it will skip like this if we keep a constant. Okay. So, how to calculate that dynamic variation of number of iteration, P as well as M coefficients? So first this equation, where it can be written like this. Okay. For example, f of x by 2d, if we take x cube plus y square, for x orientation it is written 3x square plus 0 for y coefficient. So we have this model to find the row orientation. For column orientation it is 0 plus 2y. The same we will implement in the equation where mean square error is y minus predicted means mx plus b. Okay. So our objective is to calculate dynamically rate of change of m coefficients, which is minus xi yi minus predicted. Okay. And rate of change of p is minus yi minus mxi plus b. So these two equations we will put in programming of Python, calculate rate of change of m as well as b for every iteration. For every iteration find the MSE, verify the MSE of earlier calculated, and have a best selection of suitable line. So in simplifying format, the M is written like this. The first earlier iteration M minus learning rate multiplied by rate of change of that M. Similarly, B, earlier B minus learning rate into rate of change of B. Okay, so that will give you, see for first time B1, second time B2 is equal to B1 minus learning rate into rate of change. Here B3 equal to B2 minus learning rate into rate of change. Next B4 equal to B3 minus learning rate into B. Okay, rate of change of B. This way it will dynamically change. Now let us come to the programming part. First, the library numpy. Then here function definition is written for gradient descent with two input parameter x and y. Only this much function will expand. This function will call with gradient descent function by initializing x and y array. So program x and y is initialized. Gradient descent will call. It will receive those values here, and the rest of the things will manipulate in this body of gradient descent. So slowly we will expand this code in every step. What is there in first? M current, B current, both of them are 0. Iteration 10. Length of x Then for loop will range from 1 to number of iterations. Then yp calculated, which is m current into x plus b. Okay. Cost function according to this equation. Cost function. This is the body of gradient descent. Right. Slowly now we'll expand for finding the rest of the parameters. So in addition to cost, MD, rate of change of M for every iteration, BD, rate of change for B with every iteration, right? Next, it has been expanded with finding M current for that current iteration, which is current M with learning rate into MD. According to this, it will print that M, B and cos 3 parameter will print. To stop, when to stop the iteration, for that the cost function is very much important. Yeah, now what is there at the last end of the program? We have gradient descent function with two parameters x and y, M current, B current 0, iteration 10, length has find out, learning rate is 0.001, then for loop with number of iteration, yp calculated with M current and x plus B current, cost function calculated, rate of change of M, B for every iteration, and those values are updated. Finally, we will print M, cost and iteration. These three parameters will verify when to stop the training process. So for first time, we have learning rate 0.001, number of iteration 10. Okay, let us begin with this. We will run. We got M, B and cost function. Out of them, we will use cost function to decide when to stop. It should be stopped if it is matched to the target, or it should be closer to the target. If we are going away from the target, we have to modify the parameter accordingly. Right? Similarly, if we are going closer to the target, we have to update the parameter, appropriate parameter. So, here the cost function is reducing. First 89, 84, 80, 21, 58. So, it is reducing means positive direction, going towards the target. So, it is positive. Hence, learning rate 0.001 and number of iteration 10. By keeping those, we got this sequence of cost function. Next, we modify this iteration, okay, number of iteration and learning rate, we will modify. Number of iteration 10, learning rate 0.01, and for that, the cost function 52, 30, 18, 11 to 1, rapidly decreasing, going towards the 0, right, so more positive. So it is more positive, we are reaching towards the goal, so it is more positive. So just remember, learning rate 0.01. If it is 0.1, only 0.1 with iteration same, see the cost function 105, 300, 500, 1000, 1900, 32 increasing. So it is negative. We are going away from the target. So the current combinations is not suitable for the given data. We cannot go. It is called as overfitting. It will take more computational power. Right? So this combination will not suitable for the data training. Then keeping iteration 10, learning rate reduced 0.05 and cost function has decreasing slightly. Okay, so it is positive. Next 0.08, 0.05, now 0.08. It has 70, 50, reducing, right? So still positive. Then increases iteration 1000. Up till now 10 was there, right? So it is 1000. So more times we will repeat the same. Learning rate is 0.08. 0.08 only iteration increases. See the cost 5 point something, then 4 point, very slowly variation is there, reducing. Okay, 1, and it is positive But question will come when to stop. Time complexity is important, right? So when to stop. Another version we'll see where iteration is 10,000, right? In this 10,000, cost function decreasing, but very small variation is there. So as compared to 1,000, there is no that much change in 10,000. So we can skip 10,000, keep only 1,000, right? So we avoid the complexity or overfitting. So we can stop with this combination also. In background, when we run the program, the simulation will generate the line and reach to the base suitable line, right? Whatever manually we have seen is done in background with the direct step. Based on that, we have exercise to find the score of two subjects and also correlationship between the given two subjects. So data set is student name, score of two subjects, math and computer science. Okay. And related to that, we have data set on this particular line. Yeah. If there is any question till now, only last point is left where we will see actual data training and we will stop.
Is there any, can we form a, what is the program to define the values of iterations automatically? Or we need to put it manually?
There are direct functions or tools are available. In deep learning, it will do this automatically. There is no human intervention, and which is also called as unsupervised learning. Whatever we have seen is supervised learning, where we have intervention, we provide the data, we have control, we decide when to stop, when to repeat. But in deep learning or unsupervised learning, everything happens automatically. So there are separate list of algorithms for supervised as well as unsupervised.
So, can we say that if we increase the iterations, we get more positive results?
It will totally vary from data to data. What we are verifying by changing the number of iteration impact on the cost value. We have also verified by varying learning rate. For neural network, learning rate is important. In few of the algorithm, it is also called ReLU function, cost of ReLU function, which is learning rate. So these three parameters vary data to data. Application wise will change, and with trial and error only we can come to know which is best suitable. So up till now we have seen how automatic the training process happened and how manually also happened. Both comparisons we have seen. Anything else? The last example we will see.
Yes.
Nine. Only last 10 minutes. Here in this slide, I have taken one data set and how that detailed process of automatic is done is shown over here. So we have classification, right, of lazy learner, eager learner types of classification are there, that we'll skip. We'll start with importing necessary Python packages, so import sklearn. Then dataset, to import dataset, sklearn dataset. Here we have selected dataset, breast cancer dataset, right? So we'll see the coding followed by training and testing process. So it has been loaded with this function stored into user-defined variable data. It has consist of the names, labels name given. So target can be find, target also we can find. We can find the features, name of column, heading for the data set. So if we take label name, we have two types of cancer, malignant and benign. Two types there in data set. So malignant and benign, two cancers. Features for 0 is malignant. Feature at index number 1 is benign. Two types of cancers. So features at 0, these are the inbuilt value present in the data set. Okay. For 1, we have this data set. Now further, in machine learning, this two part is very much important. Up till now we have seen training followed by testing. So we will divide the data into two parts, train and test. Randomly it will divide. For division 80-20, either 70-30 or 60-40, 50-50, anything we can do. There is no thumb rule, right? And as we change the division ratio, output will change. So we used to split with this function. It will split the data set into two parts. So for that the library is train test split, test split carrying features, label, test size 40%, random state 42. Okay. What is the output? Output is train part of the data, testing part of the data, label given for training, label given for testing will be the output. So after dividing that into two parts, we use Gaussian function for classification. Okay. So Gaussian model is created. In earlier example, linear regression was the model. Now here it is Gaussian. Fit, same example, fit. Input parameter, train and its label. Training part and its label. Whatever we have been divided into two parts. Predict function after fitting. So training, predict means testing. So we predict test data and simply print their test values. See, the output of after testing, the output is where 0 means malignant, wherever 1 is written is benign in this data set. Now find the accuracy. For that, this library is important, accuracy score. So we got accuracy, it is 95.17% accuracy. Evaluation matrix, confusion matrix is the evaluation where we have 4 parameters: true positive, false positive, false negative and true negative. 4 parameters, 4 values. This way we will get 4 values, right? So actual and predicted. So we got these 4 values: true positive 73, false positive 7, true negative 144 and 4 is false negative. Okay. Using this we can find further accuracy parameters using this matrix. So we have accuracy is sum of true positive plus true negative divided by sum of all elements. So we will do this on 4 values. So true positive plus true negative is 217 and sum of all element is 228. 217 divided by 228, it is 0.95. Same generated by inbuilt Python function. Okay. So overall it is something 95.70%. Precision, where true positive divided by true positive plus false positive, every time this value will take from confusion matrix. Okay. So in this case, TP plus FP is 80 and 73 divided by it is 915. Specificity, true negative divided by true negative plus false positive. So it is 141 plus 7, 151. 141 divided by 151, 0.95. Okay. Here also the values we are taking from confusion matrix. The same thing, whatever we have seen in earlier slide of breast cancer data set, we can implement using the classification, logistic regression, support vector machine, decision tree, Navy bias, random forest, etc. And the application area is speech recognition data set, handwritten recognition, biometric, document classification, etc. Thank you very much for your patience here. Still, if there is any doubts, we can have 2 or 3 minutes now.
Sir, my question is somewhat different, but related to techno and AI. Sir, suppose we are opening an account on any online platform, then we go through so many instructions and we just go through accepted without reading. So what are its effects?
Can you please repeat your question?
Suppose we are opening an account on any online platform, for example Instagram. Then we go through so many instructions and we just go through accepted.
It will affect on the security. Unknowingly, we are accepting all terms and conditions. Okay, so it will harmful. Without knowing terms and conditions, never accept. But normally we used to do it. Simply, we will also do it in mobile applications. Blankly we download mostly free sites, free application we download and install. And because of free, we never go to read their terms and conditions. It is totally harmful. It will take control of the mobile. It will take control of the mobile. If it is mobile application. If it is website, it will take control of your laptop or desktop.
And one more thing that happens frequently, if I am watching some educational videos and if I am hungry, then the Swiggy ad suddenly hits. Many times the related, whatever we are thinking, the related advertisements hit. So why is that so?
It depends upon the pattern of viewer, which content we are viewing. So the moment we open any application, it starts tracking to the user. It will track your single word to word, right? And based on whatever content we are currently viewing, it will start to send the notifications, browse, automatic along with that website. Objective of the service provider is to keep user engaged as maximum as to that particular content is their target, and to keep that best idea is track the user and provide the interested content. Then only we will keep your attention there. If it is unwanted data, we will exit, we will keep. Nice question. Anything else?
Anyone wants to ask questions? The time is open.
Okay, thank you very much. Thanks a lot to all of you.
Thank you, sir, for a very enlightening and insightful session. Now I request respected chairman of this technical session, Dr. Satish Shetty, sir, to kindly present the chairman's remark and share the reflection of this keynote lecture.
First of all, I thanks. Hello. First of all, I thanks to my thanks to Principal Dr. Gawani sir, IPC Coordinator and HOD Department of Physics, Dr. Abhijit Yadav sir, Dr. Renuka Londe madam, for giving me the opportunity as a chairperson for this session. Thank you very much for the informative presentation on Python. Professor Mamza sir is clearly demonstrated how Python can be effectively used for modeling complex systems and evaluating their performance with accuracy and efficiency. The discussion has highlighted the importance of computational tools in modern research and technological development. I believe this session has provided valuable knowledge and practical insights to all participants. On behalf of the organizing committee, I sincerely thank the research person, Professor Manja sir, for the excellent presentation and the audience for their active participation. With this, I conclude this session. Thank you.
Thank you, sir, for your valuable remarks and observations. Sincere thanks during this session to Professor Dr. Ramesh Mantha sir for delivering such inspiring thought-provoking keynote lecture and sharing expertise with all the participants. With this, technical session 2 comes to a successful conclusion. Thanks are conveyed to the respected chair, resource speakers and all the participants for their presence and active participation.